Hi, welcome to the last unit in this class, Earth History. Now I like to show this picture of dinosaurs because I've always thought that maybe dinosaurs come in pretty colors. So, here's an artist's rendition of what they might have looked like, but we don't really know for sure. But let's talk about geology. I don't know if you've heard of James Hutton or not, but he was the first geologist. And then Sir Charles Lyell is another important geologist about the same time. So, how do we learn about the past? Well, the key to the past is that we can look at rocks and we can determine using basic principles which is older, which rocks are older than others. So some of the principles used to determine relative age are things called unconformities, correlation of rocks, the geologic time scale, and index fossils. These are all things you're going to learn about in this unit. Absolute time is another way of looking at history, but this enables us to say specifically how old is a particular rock, a rock layer. This uses principles of radioactive decay, and there actually is a lecture on absolute time that you can listen to after this lecture. So, let's talk about these important figures in geologic time. James Hutton was a Scottish man, and he's called the father of modern geology. He wrote a book that discussed that everything we see today has happened in the past. And all of the things that we see in geology can be explained by physical and chemical processes we know are occurring today. Charles Lyell came sometime after James Hutton, and he rebelled against the prevailing thought, which at the time was called catastrophism. In other words, people thought the Grand Canyon was there because of a large catastrophic earthquake or something that ripped the earth apart. His main contribution was the development of what's called uniformitarianism. The present is the key to the past. The Grand Canyon eroded away slowly over time by a combination of a river running through it and the land uplifting. So modern view holds that processes that operate today have shaped the earth through time, but rates may not have always remained constant. So let's talk about some of the principles. Here's a principle called original horizontality. All beds, sedimentary beds, were originally deposited in water, and they formed close to horizontal because of gravity. So you can see here several layers of sedimentary rock, and they are all horizontal, one put down on top of the other. The law of superposition says that if you look at a sequence of undisturbed sedimentary rocks, the younger layers are on top, the older layers are on the bottom. Lateral continuity. Now this is a principle that explains why when you look at the Grand Canyon, you can see the same rock formations on both sides of the canyon. They were originally horizontal, and erosion cut out the rocks between them. That's our lovely Grand Canyon. There's another principle called cross-cutting relationships. If you see layers of rock that have something cutting across them, for example, an igneous intrusion or a fault where an earthquake has occurred, what this principle says is that whatever slices across must be the most recent thing. So it's younger than the rocks that it cut across, showing us a fault. So, trip through time. Here's an example, and you will see some of these in the course as you go through the assignments. But here is a illustration of a piece of land, and you can see that there is a river valley. But if you could strip away the Earth and look down inside, you would see that a lot of geology has occurred over time. When you see an illustration like this, they're showing you that that granite is a magma that pushed its way up through these sedimentary layers. Then it solidified. It looks like there was some erosion, and then more sedimentary layers were placed on top. This is an example of cross-cutting. Much deposition happens underwater. So the seafloor will have deposits put on it, and when the water evaporates away or the land lifts up, these are the sedimentary layers that you see that formed over millions of years underwater. And then there's a cross-cutting granite intrusion there. Usually right around the edges that causes metamorphism, where the rocks change due to the heat and the chemicals. An unconformity is the erosional surface you see there. So that was all washed away by erosion. The land used to be up to the top of that block, but it has all been removed by erosion. If land subsides and water comes across it again, more layers will be deposited on top of that. Millions and millions of years have gone by of land being submerged, being lifted up, being submerged. Here's more rock layers removed by erosion. A dike, that purple line going up through there, is another intrusion, and that's the most recent thing you see because it's cut across the lower intrusion and the top layers. Now in time we have the dike, the igneous rock exposed on the surface. Again, underwater, more sediments are deposited. Now you have the landscape with the stream running through it. And if that goes on long enough, it turns into this type of landscape. So this is a complex subsurface geology. Let me just show you this cross-section of Arizona. From the Grand Canyon up into Utah, you can see the rock layers and the side view of the layers of the Grand Canyon. You will have a little lesson on the Grand Canyon in this unit. So thank you very much and get busy.